Let's talk about this chopstick problem that we did during class. Now, I'm not going to go through the whole thing, but the major parts of it is, let's just say that 15% of the chopsticks are too short. Now, we take a sample, and our sample said that 19% of our sample were too short. Now, how likely is that? Well, using the standard deviation with our sample size of 500, turns out that we get a p-value of, what was it? It was 0.0007. What that indicates is this is the probability that this would happen if this is true. That's very, very unlikely based on this number. So that's why we say, you know what? I'm going to reject this value. I'm going to reject the null hypothesis in favor of an alternative hypothesis, which says that I think there's a lot more short chopsticks in there. Okay, that's the gist of what we're doing. Now let's look at the power situation. Okay, now that's where we're really kind of struggling. Okay, let's think about what we have so far. This p-value was very small. So what that means is, if it was true that 15% of the chopsticks in this shipment were short, and we got a sample size of 19%, just by chance, well, a very, very small chance. So that indicates that we think that there's more than 15% short chopsticks in this shipment. So that's kind of where we're at. Low p-value, reject the null hypothesis. So, and it's in this little area right here that we're looking. Now, let's take a look at power. So we have a specific alternative value, and that specific alternative value is 20%. So let's just say that given the situation, how sensitive is the test? In other words, how well would this specific situation pick up a shipment of chopsticks where 20% of them were too short? So that's what this is saying for this power. So same standard deviation, but how sensitive is this test to pick this up? So we would be at 0.19, right? So it's fairly likely that we would end up with 19% if 20%, 19% as our sample proportion, if 20% of the population was too short. Okay, so I guess the way you have to do this is switch gears and think, okay, when we talk about power, we're really talking about making a type 1 or a type 2 error. Okay, so basically if we're in this area, we would reject the null hypothesis, which is what we want to do. The test is sensitive enough to notice that, yeah, 20% of those chopsticks are too short. So you would have a fairly high power on this test. So for instance, what we're saying is this area is 73% of the graph there. So that's your power of the test. The fact that you would correctly reject the null hypothesis if the true proportion of short chopsticks, it's getting hard to say that, is 20%. Now, what's the probability that you make a type 2 error? That is, that you say, we fail to reject the null hypothesis. Well, you take 73, it's the rest of it, right? 73 away from 1, and you get 0.27. That's the probability of a type 2 error. All right. Not sure if that clears it up. Power is really tricky, but just remember, specific alternative value, and once you do that, you want to start to switch gears and think, okay, this is all about making the error. What's the probability that I make that type 1 error or that type 2 error? Okay, let's move on. All right, let's try a problem. So, this is about union workers. These guys look like they're mad. And it also looks like they don't even trust each other. But let's check out this situation. Okay, so here we go. Let's see. So here's the problem. A union spokesman claims that 75% of the union members will support a strike if their basic demands are not met. A company negotiator believes that the true percentage is lower and runs a hypothesis test at the 10% significance level. What is the conclusion if 87 out of an SRS of 125 union members say they will strike? Here we go. So let's see. We need null hypothesis and alternative hypothesis. So here we go. Let's see. What is it? HO is equal to what? 0.75, right? And then the alternative, what we're trying to prove is that it is lower than 75. Let me just double check that. Yeah, so now P hat is, what was it? It was 87 out of 125. So, what is that? Okay, so state, plan, do, conclude. Now, what are we going to do? We're going to do a one proportion z-test, I think is what it's called. Let me check. Yes, one proportion z-test. And we're going to do that in order to do what? Basically, we want, oh, here it is. We want to really determine, is it really 75% of the union or not? Okay. And basically, what do we do with that? So, there it is. Restate the problem. Let's see, what is it? Random, normal, independent. I'm not going to go through that, but it is a simple random sample. We could do P times N to get the normal. Independent is we're going to assume that there is over 1,250 union members. I probably would not say that the opinion of one union member has nothing to do with the opinion of the next, because unions can be pretty political, so that's probably not true. Okay, now, let's go to the next thing. So there's that. Remember, we use the proportion for the population to figure out the standard deviation now. And that's what it turns out to be. So what do we do with all that? So now we do a z-score. And they actually call this, what do they call it? They call this a test statistic. It's essentially the z-score. But let's use the right terminology. Test statistic. But it is basically a z-score. So the way we do that is 0.696 minus 0.75, what we observe versus what they said it was, divided by the standard deviation. And what you get for that is basically this whole thing turns out to be about negative 1.39. Okay. So, and again, if we go from negative 1,000 to negative 1.39, we just get this little area right there. And the calculator tells us that that is about 8%. So, let's write that down. That area right there is about 0.823. 0.823. Okay, so what does that tell us? What that tells us is that if the union really was at 75% wanting to strike, getting this sample, like this right here, Well, it's only got an 8% chance. Well, remember, we are at what is our alpha level, by the way? It says in the problem, the alpha level is 10%. So if we compare this with this, right? This is our cutoff point, okay? Now, we only have an 8% chance that would actually happen. Our cutoff point is 10%. So it's not very likely, at least for what our criteria is, which means, what do? We reject the null hypothesis. So, we say, based on this sample, we feel that the union representation, as far as 75% want to strike, we feel that it is definitely going to, well, not definitely, we never say definitely. We feel that there's a likelihood that it is less than 75% based on our statistical analysis. So, there you go. And I'm going to post it.